Hello everyone, welcome to part 3 of our image classification tutorial. Today we'll be covering supervised classification. We're again inside the European Space Agency's SNAP software, that is the Sentinel's application platform. It's a wonderfully powerful image processing piece of software with a variety of toolboxes for importing and analyzing satellite imagery, and it's free and open source. For today's exercise, we'll be using the WorldView 2 image that we've used previously, the one taken on over Darwin City in the Northern Territory of Australia. So we can just open that up and it will appear in our product explorer, highlighted there. Something we haven't shown before is this little World View tab down in the bottom here. If you don't have it there, simply go to View, Toolbars, and click on World View. What that will bring up is a globe where it will highlight the area where that product number 1 is located, and we can see this little segment covering Darwin City. Let's go back to the navigation pane and back to our image name. Right click, open RGB image window. We'll create a true color composite, red in the red channel, green in the green channel, blue in the blue channel. Say OK, and we'll have that high resolution view of Darwin City. To quickly recap, we have a variety of bands, mostly in the visible and near infrared range, and a really lovely representation of Darwin City. If we zoom in to the pixel level, we see great detail in the image. So our goal today is to classify this image through a supervised classification approach, and for that we're going to be making use of training data. For today, we won't be importing existing training data, but will rather be making use of on-screen digitisation to define known areas. Now, the tools for on-screen digitisation can be found here. We have options of drawing lines, polylines, rectangles, polygons, a few more options, circles, and some measurement and magic wand tools. We'll go through a variety of these. I would like to start by first creating a vector container. So if we click on Vector, New Vector Container, this will pop up a little dialog where we can enter the name of the vector that we want to create. Now our goal here is to classify this image, and we want to pick representative classes of different land cover types. So let's start with a very general class of water. So we want to be able to separate out the ocean from the land, so we'll call that first vector water. Click OK, and you'll see that if we open this vector data folder over here, water is included. Let's pan over the ocean, and remember that we want to collect homogeneous areas. So if we want to collect a representative sample of water reflectance, and just to remind you, if we use the optical spectrum view and we click over the water, we can see that what that spectral curve looks like, with high reflectance in the lower bands, the blues and greens, and lots of absorption, low reflectance in the longer wavelengths of the near infrared. Comparing that to land, especially green vegetation, we see quite a distinct opposite response with much more reflectance in the near infrared range. We can close that, and let's click on the polygon drawing tool, and we want to sample a range of pixels that represent water. Double click to close that, and now we have one object. As we look across this though, we can see that we have some different shades of water, possibly different depths. We want to be able to capture this range at a minimum. So let's just navigate over here and capture some of the slightly shallower portions that also make up this scene. Double click. And here we have Lake Alexander in East Point Reserve. We're not distinguishing between ocean and these inland water areas for now. So let's collect some of this. And what we're doing is really creating training data, the goal of teaching a computer algorithm to be able to identify these features. Let's zoom out a bit. And remember, the hand up here can be used to navigate. Also, if we zoom in the navigation pane, we can click and drag that window around. Okay, so now we have what is called a region of interest, an ROI. And just a few samples. Actually, it's good to always collect your samples, have a good geographic spread through the image. Let's add a broader piece down here, some of this water too. So now we have 4 ROIs in the water class. Now, in our last session, the first part of this tutorial, we looked at the scatter plot for exploring the feature space. So let's do that again. Let's bring up scatter plot, make it a bit larger, and we have our image over here and here. These are the settings for the x-axis. Exploring the feature space, we usually plot the red band against the near-infrared band, and we hit refresh to plot out that feature space. This is what's referred to as the soil line. We generally get increasing canopy closure moving in this direction over here. What's interesting now though is that we can apply an ROI mask, use ROI mask. That means use region of interest mask. We only have one class created, that's water. But if we hit refresh now, we get a zoomed in view of the pixels that we have selected in the water. And this is a much narrower axis than what we had before. And it's a little hard to visualize, but we'll come back to this a little bit later. Just look at how the axis has changed though. If we take off ROI mask, hit refresh, see this goes from 0 on the y-axis all the way up to 0.9. When we use the water mask, hit refresh, we write down 0.029. So that means that on this chart, these water pixels are really right down here, which is where we would expect them to be, having very low reflection in both the near infrared and the red. Okay, so that's water. Let's collect a few more samples. Very interested in separating out mangroves from other types of vegetation. So let's come in here, and it's a little hard to see them amidst in this current color stretch. What I'm going to do is I'm going to close the true color, right click here, open RGB image window, and I'm going to make a false color composite. So I'm going to put the near infrared into the red band, red into the green, and put green into the blue, and say OK. This gives us a false color composite, and I find it a bit easier in this view to distinguish different vegetation types. So we can see these really bright, vibrant reds. It's very photosynthetically active, and we can see how that traces some of these drainage lines. So we have mangroves reaching into this environment here. So let's digitize some of these areas that we think are mangroves. We're going to call up a new vector container again, and we're going to call it mangrove. I'm going to highlight it over here, and then I'm going to click on polygon. And we're going to capture some of these. Now when I click, it's going to ask me which vector data container do I want to use, because we've been digitizing. Now that we have more than one, we need to tell it that, yep, we're using mangrove. Say OK. And I'm going to be more careful with my placements now, selecting a number of small areas that I think represent mangroves. Luckily, our spatial resolution is very high, so even though I'm collecting relatively small areas, there's still a large number of pixels captured within each of these. Of course, this type of training could also be done in the field by going out and collecting land cover types with GPS mapping. So that should be enough for this region down here. Let's go to another part of the image where mangroves occur, up here past East Point, and let's sample some of this. And that should be enough for now. Let's possibly grab. If you're not sure of this section, this is the area by East Point. Not 100% sure that it's mangroves, so we won't include that. What we will do now is move on to the next class, but before we do that, let's go back to our feature space, analysis, scatter plot, plot the red near infrared again, let's use the ROI mask, and I'm not clicked on a band here, so if I click on one of these, I need to click on one of these bands here for the ROI mask to become accessible. Let's now have a look at mangroves. We click OK. Just make sure we have red mapped against near infrared. Refresh. And now we see where these mangrove pixels sit in the feature space. And we see, if I take the ROI mask off and hit refresh, remember this is our full feature space, and with ROI applied, hitting refresh, let's look at these values. The maximum is about 0.04 in the near infrared and 0.06 in the red. And the minimum, the bulk of the data doesn't really drop below 0.25. So if we come back to the whole scene, that means that our mangroves are sitting roughly in this region here. So to get up here, it's likely that this is more of the larger trees. We'll look at that in a minute. Let's close that. Bring up our full scene again. Now what's next? let's go for some larger trees. So vector, new vector data container. Let's call that dense vegetation. Okay, zoom in. I'm going to grab areas that I know to have very large trees. So the suburbs here. Let's head over to the Esplanade and capture some of these really dense trees, possibly African mahoganies in this region. Dense vegetation. Capture that. So usually the first couple of times it asks you which one you're doing, and after you've said yes a few times, it is happy that you know which class you're using. Capture a variety of these. If you make a mistake, you can just push. If you make a mistake, when it's highlighted, you can just use the delete key. If it's not highlighted, you can head over here to this selection tool, select it. You can select with a little window. And what you need to do is draw that box over the whole line. It will then become highlighted, and you can then delete it. Okay, so I was going to move to another region where we have some really big trees. A lot of these are in urban areas, fringes around sports fields. I'm going to collect a few more samples from these really big trees. Head into the suburbs. Some big ones. And another one over here. Move to a different region and grab some data from up here. So those are our big trees. I'll just get one more set over on East Point from this part. Okay, those are our really dense, tall trees. Let's now collect some savanna. So we're going to make a new vector data container. Let's call that savanna. Okay, and a good place to sample some of that would be in Charles Darwin Nature Reserve. And when we have a nice big homogeneous block, we can use the rectangle savanna. Okay, really sample some of that and get more of it here and some more of it over there. Do we have more of it in the scene? Let's have a look. Let's just have a look over here. Yeah, let's use some of that savanna area, and that's all I would take from here. I think the last bit we should collect for vegetation should be some of these fields. So we have golf courses and cricket fields, rugby fields, Darwin, a lot of sports fields. So again, vector, new vector data container. Let's call that sports field. Okay, and let's start down here. I'm going to use the polygon tool, sports field. Okay, grab some of this. There's another one here, sports field. Okay. So these are different because they are no trees and they're grasses, and they will be watered heavily to keep them green throughout the year. So we would expect a different spectral response. We'll grab a variety of samples from these sports field areas. And if we were being very strict, we would exclude the pitch in the middle of the field because that's slightly different. But let's just grab one more of these. And that's enough for now. Now what I'd like to show you is that if we go back to our scatter plot, check that we have the right image, and check that we have the red, near infrared, refresh, that's our feature space. Use the ROI mask. Let's see where that sports field sits. Refresh. And it's quite a high range, actually, up to 0.5 in the reflectance. And that means in the whole spectrum that these sports fields are sitting right up here. Now something that's very useful is that under the Analysis tab, we can also look at histograms, and that's the histogram of the first layer that's shown in our currently loaded scene, in this case near infrared 1. And if I refresh that, it shows us the histogram, that is the frequency distribution of reflectance values in the image for the whole scene. But if we are to select ROI mask, we could pull out the histogram specifically for the sports field and compare that to the one for savanna, dense vegetation, and mangroves. So we've selected 4 vegetation classes now: mangroves, dense vegetation, savanna, sports field. Another way to compare them is to use analysis, statistics, and what this does, again, depending on the band that is loaded, gives us the number of pixels in that band, shows us the frequency distribution. If we use the ROI masks, we can select the ones we want to compare. So in this case, we can select the 4 vegetation classes, hit the refresh button, and now we have the histogram distribution of these 4 classes. What we're really looking for is the peak and the width of this slope. From this, it would look like we can separate mangroves from dense vegetation quite easily, as well as the sports fields, because that's shifted quite a bit more to the right. Having a quick look at this, we might have more of a challenge separating savanna from mangrove, but actually the peak here is quite a bit higher than the savanna one. So I think we might get decent separability. Now, the last steps in this part of the exercise are to collect some more training data and we need to collect some examples from infrastructure, some of these buildings. Let's do that quickly now. Buildings. I'm just going to use the little rectangle and collect some of these roofs. Now, for the buildings, you'll see we have some extremely white looking surfaces, very high reflectance. We also have some other surfaces which are not so white. So let's collect a whole range of these. And again, we want to do this for different parts of the image. So I'll come down, switch to polygon because of the orientation, highlight a lot of these buildings. Really capture these surfaces. And the other class I would like to do is the tarmac of the airport, because we had some problems with that in our previous exercises and confusion with water, since it has such a low reflectance. So we'll call this tarmac. I'll use the polygon tool to capture good examples of this, especially some of these darker surfaces, which in our previous tutorials we saw that the reflectance is quite similar to water. So this should help separate water from tarmac. Into a slightly different part of the airport, and I'm collecting more here. We'll have some mixed pixels with these white lines, but this should still provide us a much better result than an unsupervised approach. We also have tarmac in other parts of the cities, bitumen as it's called here. Highways are smaller, narrower than the runway, but we can still grab a few pixels. I'll build up our training data. There we go. And one more class that I'd like to add are these dry soil, bare soil areas around the airport and other parts of town. So let's go vector data, bare soil. Remember that in this false color composite, bare soil is shown as green. But remember that at any stage, we can also close that view, open up a true color composite. If you're more comfortable with working with true color for some definitions, and we can grab some more examples of bare soil. And even these fields where we have a mix of soil and vegetation. Our goal is to grab homogeneous areas where possible. It's not always possible. It is good to build up a decent number of pixels. So there we go. That should be enough. Just to show you again, analysis statistics. If we wanted to compare the near-infrared band, so look, I'm selecting it here, near-infrared band, and if we want to compare tarmac to water, we hit refresh, and now we have the distribution, the frequency distribution of the pixels we've identified as water and as tarmac. And at first it looks like they overlap in their reflectance values, but be careful to take note of the axes, the value range. So if you look at this x-axis for water, it runs from 0.015 only up to 0.02. So really the maximum 0.02, extremely low reflectance in near infrared. We come down to tarmac and this starts at 0.05, so that this point is already far to the right of these pixels. So we'll have a good chance of separating the water from tarmac. An interesting shape to our tarmac pixels. It's not a normal distribution. We have these two different peaks, and I would guess that this taller peak comes from the wet tarmac and that this peak is more of the dry, smaller streets that we sampled. So this would be the wet airport tarmac, fresh, very black tarmac, and this would be slightly older. We can also have just a quick look at some of the ones we haven't done yet, bare soil and buildings. And again, bare soil, quite homogeneous, nice normal distribution. Quite a distinct difference in the buildings, but remember we selected those very white roofs as well as other roofs, and I think that's where that distinction would be. We would have options later of splitting this into two classes if we desired. All right, so that's all for this first part of supervised classification. We've now built our training data. So we've built up a little library that we can use to train a classifier, and that is under raster classification, supervised classification, and that'll be the subject of the next part of this tutorial. So thanks for your time and see you in the next video. Cheers.